3D Cadastre workshop. This session is about land administration in BIM. And first, let me just tell you who I am. I am Jesper Paasch. I am chair of this session, where we have five presentations, and with no further ado, I would like to give the screen to our first presenter, Hanis Rashidan, who is a PhD student at the Technical University of Alias at Baru. And the title for his presentation is Converting BIM Data to CityGML for 3D cadastre purposes. Please, the screen is yours, Hanis.
I would like to confirm, do you see my screen?
Yes.
All right. All right, thank you, Mr. Chairman, and good morning to everybody. Today, I would like to share our works on converting BIM data to CityGML for 3D cadastre purposes. I'm Hanis Rashidan, and the other authors, Muhammad Jesani and Professor Alias Abdul Rahman. We are from 3DJS Research Lab, UTM Malaysia. Today, the presentation is divided into 4 parts. The first is introduction. Here I will talk more on the motivation and also the current status of this topic on Malaysian perspective. Second is the previous work, cover on the 3D cadastre, Ifc XML, and CityGML. Next is the methodology, our methodology, which consists of BIM data filtering, 3D object extraction and conversion, coordinate transformation, and integration with Strata XML. Finally, discussion and conclusion. Okay, as we already know that stratified properties rights are registered and managed using 2 subdivision plans, especially in Malaysian scenario. So this plan do not accurately depict property spaces in complex situations, for example, the apartment and high-rise building. So therefore, the advancement in 3D GIS and BIM integration has enabling methods for modeling urban spaces dramatically and semantically. And there are several works has been explored on this topic for 3D cadastre applications, such as transformation between the Ifc and CityGML, involving semantic mapping between these 2 schemas. Okay, so the current situation of BIM to 3D cadastre in Malaysian scenario is the use of Strata XML by mapping authorities. So the use of Strata XML has some limitation for the 3D physical geometry storage. So our work is to explore the possibility to adopt CityGML for the 3D data storage. For your information, the Strata XML is a standard format developed by the Malaysian local authorities, which is to store strata data information, or in other words, the legal data, for the management and registration of strata object, cadastre object. So this study focuses on the 3D data from BIM model to support the legal ownership boundaries, cadastre attributes, and 3D visualization of the strata object. So this is the previous work based on country that related to our studies. I'm not going to explain in detail, but you can refer to in the paper. So in our work, the methodology involved 3 phases. The first one is BIM data filtering, and the second one 3D object extraction and conversion, and last is the integration with Strata XML. So the figure here shows the overall data integration from IFC model and Strata XML into 3D strata units. As we can see here from the input data, we have 2 types of input, which is the IFC model from the BIM data, and then we have the Strata XML. For the Strata XML, it contains the legal data, but from the IFC model, we extract the physical data, and then we join with the legal data using the object identifier. And then the outcome, we will obtain the 3D space in the green box, and the idea is to convert all these strata unit into 3D into CityGML. So the use of geometric data from the IFC model is to build a 3D cadastre in the context of building by conversion into CityGML format. So move on to the next phase is the BIM data filtering. In our words, we use the IFC model as a BIM data. So we know that in IFC model, they have a lot of information and data and layers. For example, we have here the IFC slab, IFC space, grid, and door. So here the process of identifying the important elements such as IFC space and IFC zone in the IFC model. So the physical BIM data, which is the IFC space filter, to create the 3D cadastre object based on the existing legal data or record contained in the strata SML. The idea is the space data can be used to provide legal boundaries in 3D, which is limited in the current 2D strata and subdivision plans. So next is the 3D object extraction and conversion. Here, the process of 3D object extraction involves the extraction of geometric semantic data from the IFC model. So the IFC space, IFC zone entities are filtered to match with the strata object in the strata SML file. So the figure here shows the original IFC model. As you can see, have a lot of data or layers like walls, roof, windows. And finally, we obtain the strata unit in the green box based on the extracted element, space, and zone. So the process of physical data extraction and mapping and conversion are conducted via data integration platform FME. So the figure here shows the snapshot from our workbench process in the FME, which is at the end we output or we convert all this data into CityGML format. So the role of CityGML is for the 3D physical data storage due to the limitation in the strata SML used by the Malaysian agency. For your information, the strata SML is a legal data contain building, parcel lot, accessory unit, land parcel, and common properties, and others are transferred to CityGML and stored as attribute information. So in our words, we use the affine transformation. So we know that in IFC, the local coordinate system is a Cartesian coordinate system. And then we convert all this physical geometric data into geographic coordinate system used by Malaysian agency, which is GDM 2000. So here, what we did, we identified the parameter involved for the transformation, because we have to calculate the correct position of the model and the real world condition, and also the rotation and direction using the transformation matrix. And finally, the integration with strata SML. Here, the integration phase involves the process of identifying and linking the extracted 3D physical object with legal data from strata object. Here, how do we combine the 3D object and also the legal data through the unique feature identifier? In Malaysia, we use this unique feature identifier to represent multi-level buildings such as apartment, commercial, and commercial building. So the linked data is output into destination format, CityGML, which is enriched with the physical and legal information. So for your information, in strata SML, it contains the boundary, the 2D boundary of the strata units. Here, for example, in the box here, they have the block, the vertex, and the boundary in local coordinate system. So this is the output, the method. So our method for converting BIM data to CityGML for 3D cadastre purposes to support the legal boundary, ownership boundary in 3D space, and also at the same time to enable the ability to query cadastre attribute, and finally to 3D visualization of the strata unit. So the figure here shows the outcome of the conversion. As we can see, the 3D strata units are overlaid on top of the terrains, and then we're able to click on that particular blocks or unit to get all the information, the legal properties. So in conclusion, the conversion able to produce strata data into CityGML-based format building with several floor and strata unit, and furthermore, especially the ownership of the strata unit can be identified, such as block, building, accessory, and land parcel. So this paper strongly believe that the work obviously require more attention in the aspect of physical geometry data filtering, matching, and also the semantic data mapping. So currently, the work only focuses on the possibility to harness the IFC data to combination with the existing 2D record of legal data in that aspect as part of addressing strata-based cadastre in Malaysia. So important aspect of 3D cadastre such as RRR will be investigated further in the near future. Okay, that's all from me. Thank you so much for listening.
Well, thank you, Hanis, for a very interesting presentation. And you did not use all your time, but that gives us only more time for questions.
Yeah.
So, I would like to ask anyone, do you have any questions? Because you have not posted anyone in the Q&A. But do you have any questions? We have quite good time, actually. Well, if not, then I have some.
Okay.
No,
I think there is.
Sorry.
I think there is one question on the chat.
No, I can't see it on the chat.
Q&A.
Yes, I can see it here. Yes, here it is. Yes, sorry, it was some delay here. They're actually coming in now. There are 3 votes for one question. Are there good ideas in the FIC data sets you tested?
Oh, okay. The data set we use is the local data set, and we already experiment with some open data set, and also our local data set that contain with the legal data. Is it answering the question?
Okay, thank you. Then another question: how good is the georeferencing in the FIC files you tested? From Peter. Hanis, did you hear the question?
Sorry?
Did you hear the question? It is how good is the georeferencing in the IFC files you tested?
Okay. Actually, it depends on the parameter, because we identify, we calculate the parameter to do the transformation. For example, we try to find the position, some control point in the IFC model, and then we calculate the parameter using the transformation, and then all the composition will calculate and then transfer all the vertices into the GDM 2000, our local coordinate system.
Thank you. Another question: what to do with curved boundary surfaces?
Sorry, what to do with
curved boundary surfaces?
Curved boundary. For now, I'm not sure I can answer this. For now, we haven't come across with this situation. We have the curved boundary. Maybe there is a look topic to study to look more into this aspect.
Good, very interesting topic actually. Also with the curved boundaries, because they are most buildings today, or newer buildings, may have curved boundaries. And then another question: whether identifiers in the IFC files do they link to legal information?
Oh, how we link. So actually in the IFC file, they have a lot of data that what our finding is not all the space data in the IFC file can be utilized for the 3D cadastre, because in this aspect, we try to overlay the 2D data in the strata XML and to validate with the 3D object that we extract. And we come across that there is some condition, some condition that not all data from the IC can be used what is it. So they have to, maybe there is another study to look into how we can map or we can modify all this based on the 3D cadastre object. I hope that's answering the question.
Thank you. And then another one, data conversion from BIM data to IFC data creates errors in representing the curved surfaces. Do you consider any data validation before converting IFC to CityGML?
Okay. Data validation. For now, this is the early stage of the works experiment. We just try to our test only for small data set on not many building. We extract the geometry, IC space, and then the process of validation is actually the manual process, semi-manual, because we have to identify whether the space extracted is it really represented the 3D, what we call the 3D ownership of that particular strata unit. Yeah. Very good question. I think maybe in the next future is maybe we need more words or look into more detail how this mapping or how to improve in terms of the accuracy of the conversion.
Thank you. And also, there are popping more questions in. That's very nice. To what extent of the BIM model? To what extent of the BIM model you used? Is it an as-built BIM?
To what extent of the model? Maybe I understand that what type of BIM model. Here we use the IFC 4.0 models, and then yeah, I think we use that data, the model.
Good. Maybe I'm not so familiar with that Q&A yet.
Okay.
I cannot see so many new questions, but I have one, if I may. That is, you talk about ownership legal as a legal entity, but there are many other entities, rights and restrictions, responsibilities. Have you considered how to collect these and include in a BIM? Because it can very fast be very complicated.
Yes, true. Actually, in our words, yeah, it's true that in legal ownership we have three R, right? But in this study or in this work, we try to get the possibility how to extract the data from IFC into the cadastre. But actually, we don't involve with more detail or more deep into the ownership, because we just link the existing legal data from the strata XML and join the geometry. In the future study, like I'm highlighting here, it's very true. Like in the future study, important aspect of the triple R need to be investigate more. Yeah, I hope that's answering the question, Mr. Chairman.
Thank you. That what I think may be the last question for today, because we're running a little out of time, almost. But Peter can correct me if I hurry too much. But the volumes of the walls and the slabs, are these added to individual units or to the common/shared space?
Walls and lab. Oh, okay. Yes, there is a possibility, but I'm sorry because in our works we just try to harness the IFC space and IFC zone for the modeling of the 3D cadastre.
Good.
I hope.
Thank you. I think the time is up now.
Okay, thank you, Mr. Chairman.
And thank you for a very good presentation and good answer to the question.
Thank you.
Then I would like to switch to Gerhard Navratil, who is a senior researcher at the Technical University of Vienna, and he will talk about a 3D cadastre in the case of engineering objects, such as bridges and road viaducts. Please, Gerhard, the screen is yours.
Thank you very much, Jesper. I'm talking on behalf of a quite large group of people. So the main person, so the person who was mostly trying to kick us in the butt was Marcin Karabin from the Warsaw University of Technology. We have Dimitrios Kitsakis from the National University of Technology in Athens, Mila Koeva from University of Twente and ITC. I'm from TU Vienna. Jesper Paasch is from University Gkeli and Landmeteriet. Jenny Paulsson is from KTH. Nikola Vucic is from the State's Geodetic Administration in Croatia. Karel Janecka is from the University of West Bohemia, and Anka Lisec is from the University of Ljubljana. The advantage of having such a big group of people with such a different background, so being from various countries, is that you get a lot of information about the national situation. And we were trying to put those things together. So we, as a discussion group, I think we started back in 2014 when we had a discussion in Dubai about legal issues. And I think that's when the core started of our project. And we had a paper last time in 2018 dealing with subways. So we were discussing how subways are documented in different countries. And we found out that there is a number of ways to do it. Not all of them are using 3D. So typically, only a limited number of countries actually use three-dimensional solutions to register, to document underground. So mainly the underground lines were modeled in 2D. The principle that the countries followed was a superficies solocedit, and sometimes there were large disadvantages for landowners because it was not clear where the underground was going. So no vertical separation, no clear vertical separation was done. And the case of Sweden in that paper already showed a solution that is based on three-dimensional data, and that's actually working. So we continued this time, and because we saw that the solutions seemed, also the problem seemed to be unsolved in cities. So we thought about, okay, most of the cities worldwide do not have underground lines. So how about something that every city has? How about bridges? How about viaducts? We do not only have them in cities, but throughout the country. So there should be better solutions in the countries there. Bridges have already been discussed in the 3D cadastre workshops. In 2012, there was a paper by you et al. Showing the bridge connecting Hong Kong with the China mainland. And this is an example of a 3D cadastre because the bridge belongs to Hong Kong, the water below belongs to China. But since bridges are a part of navigation networks, we do have them as a problem throughout the world. So the picture here on the bottom right shows a bridge crossing the Blue Nile in Ethiopia, and the picture was taken from another bridge right next to this one. So we do have the situation of bridges throughout the world. So we just were trying to collect information from all countries represented by the authors. And in alphabetical order, we have the countries Austria, Bulgaria, Czech Republic, Croatia, Greece, Poland, Slovenia, and Sweden. So we have quite a number of countries represented, but obviously it's not a full coverage or some selection based on reasonable criteria. It was a selection based on authors contributing to the papers. So have a look at Austria. If you look at the situation in Austria, then bridges are not shown as cadastral parcels. What you see in the cadastre is, as you see it here on the right, we do have small rectangles. That's the pillars of the bridge, and the bridge is this one. It's the Europabrücke, so European bridge. When it was created, it was one of the highest bridges worldwide, some 150 meters above ground. And you see those are the pillars here, and the red ellipse shows the position of the bridge. The position of the bridge itself is not shown in the Austrian cadastral map. It is documented, however, as land use. So on the parcels below the bridge, you see that the land use changes from agricultural use to traffic space. And that might be important, an easement is registered in the land register, showing that there is a bridge above these pieces of land. If we're going to Bulgaria, in Bulgaria, bridges are no cadastral objects either, so they may or may not be depicted. And we have here two examples. In this example, there is a small geometrical representation of the bridge. In the left picture, yeah, it's just a standard cadastral boundaries. So no representation of the bridge at all. In the Czech Republic, it is possible to represent 3D objects schematically on the cadastral map, but that's only done for some three-dimensional objects, and bridges are typically not part of that. What we do see here is, again, pillars of the bridge are shown in the cadastral map because they are connected to the ground. The bridge itself is invisible in the cadastre, and that's a highway bridge near Paulsson, so also it's a quite important bridge. If we go to Croatia, Croatia uses topographic signs showing three-dimensional solutions. So they have a 2D representation. The line style changes if something is below the ground. So here it's a passage below a building, above something. So this is a building over a road. You see the road is connected here, and on top of that, the building connects the two sides. And Croatia also has an interesting other. The is connecting a peninsula with a main island, and it's not registered because obviously the wall Mediterranean Sea, and the cadastre doesn't cover that. In Greece, the landowner is obliged to provide land for bridges. Of course, they get compensation, but that makes the bridges and viaducts public space. So that the parcels follow the road network. However, it is more or less arbitrary if the parcel is based on the direction of the road below. So both might happen. In Poland, bridges are documented, but in a database of topographic objects. So bridges are not at all registered in the real estate cadastre. They do not show up. In Slovenia, bridge and the land below the bridge have the same owner, so it's difficult to separate those two. It is obvious that there is a legal challenge, so the administration knows it, but it's not yet solved. So you see here, there is a bridge, but apparently the river just... The owner of the river is also the owner of the bridge, which is in reality will not be the case. And finally, we have Sweden. Sweden does have the possibility to document and register 3D property objects since 2014. And a 3D property unit has an indicated type of space. And one of the possibilities is bridge. Our two colleagues from Sweden looked it up, and they found 15 bridges that are currently registered in Sweden. However, there are no pure 3D objects. The example shown here is this part is a bridge connecting the two buildings. This here is a pure part of the building or building itself. So typically it's not bridges per se that are documented, but it's bridges that are connected to some other construction. So what were the lessons that we learned from the discussion? We had 8 different countries, but only Sweden has a working registration of 3D property. Of course, there are other countries that do have 3D property registration, like the Netherlands, or countries who are much closer to having that. I think Israel and the Turkey are on a quite good way. But there seem to be solutions in all the other countries as well that are more or less working. So we've seen a lot of different possibilities, from just documenting the legal connection with an easement, use separate parcels, have a distinction by land use, use a separate object type for topographical objects, or even document things like that outside of the cadastre, or, which is the worst, probably pure ignorance. So all these approaches seem to work, at least to an extent where the public uproar is not big enough to cause politicians and lawmakers to find better solutions. So it would be interesting in the future to check what is the positive or negative effects, economic effects or legal effects of these solutions, to find arguments why we should invest more in this direction, or whether the possibilities that we are, or the solutions that are currently implemented, are good enough. So I used my time. Thank you very much. And I'm open to discussion. Thank you.
Thank you, Gerhard, for a very interesting presentation. And we have one question so far. It is there any need for bridge legal space modeling at the international level, say LADM ISO 19152 edition 2? What do you think?
I don't think we need to have a specific solution for bridges. I assume we need to have a specific implementation issue for all kind of networks that we have. It may be tunnels, it may be bridges, so traffic networks, can be sewers, water supply lines. So we need solutions for that in order to document them in a neat way, in a way that we understand the limitations. For example, if you're thinking about oil pipelines, if something goes wrong, the environmental implications are tremendous. And the same happens if a bridge collapses or a tunnel has a fire. That may also have an impact on the surface.
Thank you. Next question. What about bridge IFCs? Are they used?
I haven't seen anything like that.
Neither have I, actually.
And you're closest to a real three-dimensional cadastre.
I would not claim that, but thank you. It's working.
Being a representative of Sweden, I thought.
Yeah, it's well, it works fine actually. The next question. Regarding the bridge that extends into the sea, what is your opinion on the method to register this ownership?
I think that's a difficult issue. I think the best way might be to take the two endings of the bridge and connect the right to those two endings and connect them with a bridge. And then, since both endings are on the mainland and are part of the cadastre, you can cross anything that's not in the cadastre between those 2 points. Because I'm not sure about the open sea, if that can or should be part of a cadastre. But Austria doesn't have access to the sea, so we're not used to that kind of problem.
Well, there are some limitations I can see. But let's go to the next question. Have you identified any patterns on the registration of such objects at the various countries who studies? What kind of technical data / formats are being used?
The discussion was not going that deep into the technical details. We were mainly discussing the legal and administrative concepts used. I think one of the next steps could be to look at what kind of data, what kind of formats are used. I know it from Austria. It's pure CAD, 2D CAD that's used for the registration. So AutoCAD, more or less. Oops. Jesper, you're still there?
Yes, I'm back. I was thrown out.
Okay, I'm back.
But I'm back.
Okay.
But thank you, Gerhard, for a very interesting presentation of a very interesting topic.
Thank you very much.
And now I would like to give the screen to Rohit Ramlakhan, who is a master student at the Delft University of Technology, and the presentation is Modeling 3D Underground Legal Spaces in 3D Land Administration Systems. Please, Rohit, the screen is yours. Your microphone.
Can you hear me now?
Yeah.
Yes, okay, sorry. Okay, thank you. My name is Rohit Ramlakhan, and the other authors of this paper are Eftychia, Kalogianni, and Peter van Oosterom. I will first start with an introduction into the problem and a motivation why this research was done. Then follow some related work, the objective of this research, the methodology, the results will then be presented, and the presentation ends with a discussion and conclusion. Urbanization has led to the development of multi-level properties worldwide. The implementation of these multi-level properties in land administration systems requires 3D objects below and above the surface. 2D land administration systems cannot represent the 3D legal reality well. It is not easy to identify the ownership of underground objects, such as tunnels and utilities. The relations between the objects below and above the surface are also not explicitly provided. A 3D land administration system, however, can clearly define the relationships between the rights, restrictions, and responsibilities and the 3D objects, while the registration of these objects will facilitate a better understanding, more efficient registration, and a clear visualization of the RRRs. A 3D land administration system can therefore support the decision-making in urban development. A need for data exchange and interoperability across the architecture, engineering, constructor, owner-operator community, industry, and government has resulted in increasing use of BIM IFC models. The implementation of the land administration domain model in a 3D land administration system will result in easy determination of the RRRs of underground objects. Although the implementation of these standards has supported the development of land administration systems, the challenges still remain that the 3D land administration systems vary around the world, which results in different requirements for the collection, validation, registration, dissemination of 3D underground cadastral data. First, the situation, how it is now in the Netherlands. There are 3 types of cadastral objects: parcels, apartments, and utility networks. The utility networks are registered as separate legal objects in the Dutch Cadastre and as physical objects by the utility network companies. Other underground objects are not cadastral objects. However, their property rights can still be registered with the use of limited rights on 2D parcels. Limited rights are the right of superficies, the right of long lease, and easements. Superficies, the right of superficies is that you can construct a building or structure on top or below another structure or land, even if it has a different owner. The right of long lease means that you can use an object that belongs to a different owner, and easements are burden on a parcel that another parcel has certain rights over. The Dutch Cadastre also adheres to the specialty principle, which means that if a limited right is attached to a part of a parcel, then the whole parcel needs to be divided in such a manner that the parcel with the limited rights attached to it will not intersect with parcels that do not have the same limited right attached to it. A workflow has been developed by Stoter et al. With regards to the registration of multi-level properties with underground objects in 3 dimensions, where the legal volumes were created from BIM models and validated. With the use of a 2D cadastral map, a 3D PDF was created for the visualization of the legal volumes and to be used as a legal source document. The legal volumes created were also stored in the Dutch Cadastre for the 3D geometry. However, it was not possible to extract coordinates from a 3D PDF, thus the use of BIM IFC models is preferred. The land administration domain model is a conceptual model that provides formal language for describing both spatial and non-spatial information in the land administration domain. Currently, the revision of the first edition is ongoing. That is in order to improve and refine the modeling of land and property rights and to extend the scope of the model, which will result, among other things, in increasing support for different types of legal spaces, for example, utilities, and including technical models, for instance, BIM IFC models. The Industry Foundation class IFC is a standard for BIM models and contains requirements for data applied to buildings throughout their life cycle. IFC files made during the design phase could be reused for land administration purposes, since they contain geometrical data and other information that is necessary to register the property rights. Reusing and sharing IFC files throughout the spatial development cycle could lead to a reduction in cost, higher efficiency, and better decision-making. The objective of this research is to develop a standardized workflow in order to collect, process, store, visualize, disseminate, and query 3D underground data in a 3D land administration system according to the LEDM standard, to model the relations between underground objects and their legal spaces, to model the relations between underground legal spaces and 2D parcels on the surface, to connect the workflows from AEC 00 to 3D land administration systems via a BIM IFC model. A literature review was performed where the objective was to define the aspects that need to be part of the workflow. The articles were retrieved through an online search through journals and repositories. The first selection was based on titles and abstract. The second selection was after full text review, based on how relevant these articles were to the research. The references of these articles were also searched and evaluated, and if they were deemed to be relevant, then they were also included. To model 3D underground legal spaces in a 3D land administration system, the workflow that is presented here can be used, where the workflow is divided into 3 phases: conceptual modeling, physical modeling, and visualization. First, a UML model that describes the relations between the underground objects, the tunnels and utilities, and the 2D parcels is created. Then the BIM IFC models of the underground objects are collected, investigated, and validated by assessing if they comply with the IFC schema, if they comply with the guidelines provided by the government, and if they have the element IFC site with the correct geographical coordinates, ref elevation, ref latitude, and ref longitude. Then the LDM classes are, the elements are mapped to the BIM IFC elements, yes, where where different types of IFC models IFC elements can be used to store the legal information, of which IFC space is the most important one. Then a database is set up with the use of PostgreSQL and the spatial database extension of PostGIS, making it a spatial database. In this database, the BIM models and the 3D parcels will be stored. The parcels, 2D or 3D, are retrieved from the cadastre. If the parcels contain 2D objects, then they first need to be extruded to 3D with the use of a data integration platform such as FME. The enriched BIM IFC models with the legal data will then be stored in the spatial database, where in 2 tables, where one table will be used for the legal model with the legal information according to the LEDM, and one will be used for the physical model with the BIM IFC data. Another database, a 3D topography database, can be added, where, for example, a local digital terrain model can be added, since they are more accurate than global ones, or a 3D city model can be added, since they can be used as reference. CityGML, a 3D geospatial visualization platform, can be used to visualize the whole integrated model. Well, the objective of this research was to develop a workflow that provides the user with a framework on how to model legal spaces of 3D underground objects in a 3D land administration system. The upcoming revisions of the LEDM and IFC standards were not taken into account when developing the workflow, so it is not known how these revisions will impact the workflow. Only BIM IFC models of buildings with limited underground objects were available for use, making validation of the workflow not possible. So we are still searching for BIM IFC models with underground objects that we can use that are not limited. So this workflow was the first initial attempt at developing a standardized manner in order to model 3D underground legal spaces in a 3D land administration system. In order to further develop and improve the workflow, more research can be done in validating the workflow with use cases of BIM IFC models of underground objects, investigating the option to include data formats other than BIM IFC in the workflow, investigating and improving methods to convert other data formats to BIM IFC, assessing the impact of the revisions of the LEDM and IFC standards on the workflow, and investigating how the workflow can be adapted in order to comply with the revisions of the LEDM and IFC standards. I would like to thank you for listening, and are there any questions?
Thank you, Rohit, for a very interesting presentation. And yes, there are questions. We have the first question is what do you prefer to use for theta values? Relative Earth to Earth's surface, or absolute values in national or international vertical reference systems?
I think we will prefer to use absolute values, since the relative values may change if, especially with underground objects, if there's, for example, they have construction works, etc., then they might be moved or changed. And I think absolute values will be more reliable.
Mm-hmm.
So, yeah.
Thank you. Sorry. Next question. to what extent are Dutch utility companies used BIM to represent the underground infrastructure?
Well, we just had, I think, a couple of weeks, we had a meeting with such, well, actually a company that works for utility companies, and they said they do not use BIM as much for utilities since it is expensive, although it does have to do with the conversion of other formats that they are currently in. And they said if it's possible to convert other formats to BIM, then it might be easier for them to use, and maybe they would also start using it. So it's not so much used now, I think.
Okay.
But it could be in the future if we have better alignment with other formats.
Understandable. Thank you. Next question. What about underground BIM IFC data of underground parts of buildings? Did you check this?
Well, that's basically the what I said with the limited underground objects. We did find some test samples where the building had a little bit of utilities going underground, but usually those utilities are also the ownership of those utilities are also part of are from the same owner as that of the building. So it might not be interesting enough to, since you want to describe different owners and different settings. So, yeah.
Understandable. Then next question, do you recommend using IFC for a city scale underground network?
Well, it's kind of hard to say for me now, but yeah, there are some, especially with BIM IFC models, there are some problem when you have extending objects, so longer and bigger objects. But I do think that maybe in the revision, they do pay more attention to utilities, etc. So maybe the revised version will be useful for a city scale underground network.
And then if there is no BIM IFC model available for utilities, but another format is dominant, for example, DXF, land, XML, and so could that not be used for a standard workflow?
Whereas, like I said, they also currently use other formats, but it might be useful to also extend the workflow with possibilities to use other formats and first convert them in such a sense that it can be integrated in the same workflow, like a modular approach to our workflow with different modules for different formats with eventually the same result.
Yes. I think we have time for one or two more questions, so don't hold back. Well,
I think there's one more, right?
Is there?
I'm not sure.
Then we put out and I have. Now that I see you, I think you covered them.
Okay. Yes.
Well, thank you for a very interesting presentation and good answers to the question.
Thank you. Okay. Bye.
Bye. And now I would like to welcome Marjan Broekhuizen. Marjan, are you here? No, she is not. And your sound is a bit strange. We can see your screen, but we cannot hear you. Yes, now it's better, yes.
Kijk. Thank you very much, Jesper. It's also... yes, so you can hear me now correctly and you can see my screen, right? Yes.
Yes.
Okay, thank you very much, Jesper. I'm going to present today our research on BIM models as input for 3D land administration systems for apartment registration. And yes, this work was together with Eftychia, Kalogianni, and Peter van Oosterom. So our work is in the context of a 3D land administration system for, and specifically the Dutch land administration systems. As was mentioned before, in many ways, 3D could complement the land administration systems, because for some multi-level properties, 2D maps aren't sufficient. But if you want to make a 3D land administration system, you have to have input data. And this research focused on using BIM IFC files, and more specifically real-world BIM IFC files, as input for a 3D land administration system in the Netherlands. So in this presentation, first I will present the research questions. Then I will present some background on the Dutch land administration system, the LADM, and also BIM IFC. Then I will present the case studies. Then I will present the research methods, which include the validation methods of BIM IFC models. Then I will present the results. And then there's some time for discussion and conclusion, and for some questions. So the main research question is, how should BIM IFC models be designed to effectively be reused as input for a 3D land administration system? And we focused on the technical complications when trying to use BIM IFC models as input for a 3D land administration system, but also possible solutions. And the focus also is on real-life BIM IFC models. So some background of the Dutch land administration system. As you can see here on the left, there is a cutout of the Dutch parcel map. And as you can see, the building on top, it rises over other property. And in 2D, it's really represented flat, in which every parcel number should does represent multiple rights, but it's not clear from the 2D map how it really is in 3D. And I'm sorry I have timed presentation, but yeah. So 3D could give a more better representation of the situation than 2D. And on the right, there is an example of how such multi-level property is now registered in the Dutch LAS. And that is done by apartment rights. So you've got one right, one parcel, and it is divided in a division, a deed of division. As you can see, there are multiple stories, and the thick lines, they represent the boundaries, and there is also a representation of the stories. But this is still a simple situation, but you can imagine that more complex situation, this is also maybe not sufficient, or 3D could also give a clearer insight. So for this research, we use BIM IFC models. And why are we using them? As Rohit actually said before, the BIM IFC models are part of a spatial life cycle. They are meant to be used in the design stage, but as well as the building stage and renovation stage. And at the core of BIM is also sharing and reusing data. And therefore, it's also interesting to look at the possibility of using BIM IFC files as input for a 3D land administration system. Now, as you probably all know, IFC files are an open format, which makes it very useful to, very open to use as a 3D in the 3D LAS. And something about the land administration domain model. You may be familiar with it. It is a conceptual model to of an object type library to represent a land administration system. And for this research, we also linked this land administration domain model to the BIM IFC files. And this is done. The BIM IFC models, they represent the blue package, the spatial units. But as has been mentioned before, there is still ongoing research on how to further implement that. So on to the case studies. We collected 5 real-world BIM IFC models. So these are models of real buildings which were really used. The 2 models from Utrecht are still under construction, so they are as designed. But yeah, they are both located in Utrecht, and as you can see, they have some interesting 3D components which might not be represented well in a 2D parcel map. So how is this research? What are the methods? Well, first of all, we contacted some user groups and collected data from the real world, and they were used as the input for a 3D land administration system, which is the core of this research. But what is also important are recommendations and guidelines to how to construct or design a BIM IFC model so that it can be used in a 3D land administration system. And for this, input is used from the environment as well as from the literature. So we consulted the user groups, but we also consulted previous reviews and related prototypes. For the validation, we use the BIM IFC models I have just shown, and we set 4 validation rules to which the BIM IFC model should comply to be technically feasible to be input for a 3D land administration system. And the first is the availability of uniquely identifiable volumes. And this is IFC space in this case, but they should also include a link to the Dutch LES. So for example, an index number or some unique identifier which can be linked with the Dutch land administration system. They should also have valid geometries, and they should also have non-overlapping spaces or gaps, and they should be able to be georeferenced well. For these validations, we used a combination of FME desktop together with Postgres, and in the end we made a representation in online. I will now show how we validated these models. Yes, and here is the scheme of which first there is a validation, then it is uploaded into a database, and then they are converted to 3D tiles. So for the legal space, it's actually a simple validation. We checked in an FME desktop workspace, is there IFC space available? The index number, because there are no standards or mandates on how to include the index number for the Dutch LES, was somewhat more difficult. So for that, we looked at the names of the BIM IFC models, of the names of the rooms, and tried to find if there is a pattern in that. But we could not automate this process. So for the validity of the geometries, we looked at the OGC, if they are complied with OGC, and also if they contain any non-planar or two-sided planes. The spatial relations were somewhat difficult because we were looking for a way how to get a D9M model. But in the end, we first converted them into a Postgres database, and then we did a 3D intersect. And with the remaining volumes, we checked, are they planar or are they volumes? And based on that, we checked if there is any overlap in the models. For the georeferencing, we integrated Ifc Geo Ref Checker into the FME workspace, which checks which attributes are available to georeference a BIM IFC model. So for the results, I will focus on the legal spaces and the georeferencing because those are the ones with the most red spaces. We noticed for legal spaces that only 2 out of 5 models actually contained IFC space, which is viable to represent the rooms. But also those rooms did not contain any index number or link to the Dutch LES. So that is explainable because there is no standard or mandate to include that, but it would be very viable if there was such a mandate or standard. And also BIM IFC models should contain IFC space. The georeferencing was also not possible with all of the models. Some contained some information and a reference point in the BIM IFC model, but they were missing information about the transformation or scaling of the model. So the results can be seen at this link. I will skip this for now because of the time. It's a simple visualization, but the focus was on the validation. So based on these findings, we have formulated some recommendations and guidelines for BIM IFC models to be designed. First of all, rooms have to be included in the BIM IFC model as IFC space. Also, they should contain a property set which include the apartment index number, cadastral parcel number, complex number, space type, and municipality to link them to the 3D LES in the Netherlands. And also attributes for georeferencing should be included in the BIM IFC model. And it is recommended that IFC4 files are used because they have better attributes which are capable of georeferencing. And for existing models, it is not necessary to enrich the IFC files with attributes complying to low GeoRef or low GeoRef 40. And this was based on technical complications, but of course, to implement these changes and also recommendations and guidelines, it would be useful to also investigate legal and organizational issues to see if these recommendations and guidelines can be implemented. Also, this work is focused in the Netherlands, but this could also be extended to maybe other countries. And another point to note is that BIM IFC files were collected, but there is only they are not open files often, so you really have to collect them, but there are not many openly available. So yeah, this was the presentations. Are there any questions?
Thank you.
Yeah.
Mine for a very good presentation. And yes, are there any questions? And yes, there are. First,
Yeah.
we have one. If there is no IFC space, how do you check if the 3D and geometry is valid?
Yeah, that's a very good question. In most of the research, we focused on IFC space, but with the validation of the geometry was an exception. I validated every geometry, so also the walls and other building elements. So yeah.
Thank you. And the next question is, could you reflect on using together 3D legal spaces, parcels, and 3D physical objects?
Yeah, that's a very interesting one as well. Could you reflect on using together 3D legal spaces and 3D physical objects? So I think you mean the parcel numbers. Yeah, it's an issue because the 3D land administration system knows a certain numbering for their parcels, which is a uniquely identifier, which is necessary for a 3D land administration system in the Netherlands. But you want to link them to the IFC file, and that is only possible if there is a reference in the IFC file to this number, or if you can relate them in any other way. And this is not possible. So for this, for example, it should be included as a standard or a mandate that if people are designing BIM IFC files, that they should also include these index numbers in the BIM IFC file. But that is not true right now. So therefore, it's hard to link them together.
Thank you. Next one is who should be responsible for LFC space and to validate the legal spaces?
Yes, well, that is a question that I cannot answer, but which the politics or lawmakers actually should answer, because well, if a BIM designer is tasked with making a BIM model and is not given instructions to include IFC space, then they probably wouldn't. So someone has to say, okay, if you want to use this BIM model, for example, apartment rights or building registration by the municipality, you should include this and you should include this. So yeah, who's responsible for that? Yeah, that's really a interesting legal or organizational question.
And that also leads to next question almost. How would the recommendations look like? Text, some formal logic, and how to enforce them?
Yeah, well, currently there is already in the Netherlands a BIM loket which mandates certain things to be included in the model, but it's more a recommendation than really a mandate or yeah. How do you say it? It's optional, but I could imagine something like those, the recommendation and guidelines, to be integrated in the recommendations and guidelines of the existing BIM loket, and it would really help if those guidelines were not only guidelines for people who want to use them, but that they were that they are made like how do you say that?
Mandatory.
Mandatory, yes, thank you. Yes, so yeah.
And the next question is more of the technical nature. FME can convert all types of geometric representation IFC to PostGIS, OGC. IFC has so many ways to model 3D.
Yes. If I'm looking for the question, yeah, but that's actually an issue. You can FME can transform a lot of formats to other formats, and it's hard to choose the right one. And also, especially for validating the models, some validations in PostGIS and FME only work with a certain geometry type. But then you also have to look, am I using the right geometry type? Am I using the right validation? And yeah, is the result really what I meant it to be? So yeah, IFC has many ways to model 3D. That's true.
Yes. And next question is, as IFC is gaining ground, do you think that if the recommendations proposed are followed by designers, there would be an automated workflow to register 3D apartments at from IFC models?
I think that should come both from the designers, but as well from example the Dutch Cadastre or the politics, to really create such a workflow that for the designers it is known where do I have to comply to, and then you can make it automated. But for now, the automation is very difficult because we also talked to, for example, the municipality of Utrecht. He created a digital twin, and he said, well, it's nice, all these BIM IFC models, but they are all structured differently. So if I get a lot of these BIM IFC models, there's no way I can include them in my digital twin because then I have to spend hours on each model to transform it. So yes, an automation is possible, but then there needs to be better agreements and standards.
Yes, and that also connects to next question, that manual creation of ownership information on top of building structures would be very error-prone and heavy workload work. Do you have any recommendations on how to automate the creation of a model?
So let me see, manual creation of ownership information. Yes, I think what is meant is that it would be a lot of work for the designer to implement these index numbers and other property information in the BIM IFC model. Yeah, maybe it should be a joint task of designers and legislations. I don't know, or maybe it could be automated if, for example, the index numbers are already known, that they can be automatically linked to the rooms. But yeah, I don't really have a sufficient answer for that, I'm afraid. But
yes.
it's an issue, yes.
Yes, we have some answers still, some questions still. I think we can manage some of them. Is your checking software open source?
No. I used FME Desktop, which is proprietary. So yeah, many universities do offer it, I think, at the geometric department. So that part isn't open source. Postgres is, and actually I found at the beginning of the research I intended to use a lot of FME, but then I also I found out that Postgres actually also has a lot of options to validate and check 3D models. Yeah, but it's not open source, right? But you can check everything. If you do have FME, you can check everything at GitHub. I think I included the link in the presentation.
Yes, thank you. And another question: in the case of a municipality gives a permit only when a proper BIM IFC model is submitted. Could this be an option?
Yes, yeah, I think that's a very good checking point for the flow of data, where municipalities can actually reject or accept a model, and that would also urge designers to comply to that model. But that does need some regulations between the municipalities and also the designers. And also municipalities need to be ready for that, because what Menno said, he provided the model in Amsterdam. He said, well, we have great BIM IFC models, but then we submit it to the municipality and they make our 3D info, they make it 2D. So yeah, the municipalities also need to be ready for that.
Yes. And that brings us to what I think is the last question. How would her recommendations look like? No, that we have had already. So I think we have gone through the list of questions.
Okay, very nice.
Thank you very much for a very interesting presentation and work and answers to questions also. Then, last but not least, I would like to give the screen to Gkeli, who is to a student from the National Technical University of Athens. She will talk about linking LIDM with BIM IFC standards for mobile-based 3D crowdsourced cadastral surveys.
Okay. Thank you very much for the introduction. Hello, my name is Gkeli. I'm a PhD student of National Technical University of Athens, and I would like to present to you a project entitled Linking LADM with BIM Ifc standards for mobile-based 3D crowdsourced cadastral surveys. The ongoing urbanization has led to the construction of complex buildings with multidimensional property rights. So far, traditional cadastral procedures have often led to increased costs and long delays, making the completion of first registration difficult or even impossible for many countries. In the meantime, many cities are mapped in 3D at various levels of detail and constructed and managed by building information models. Through integrating the existing BIM with modern technological achievements, web services, and crowdsourcing techniques, the development of a reliable, qualitative, and affordable solution for the initial implementation of a 3D cadastre is feasible.
Maria, do you have slides or not?
Yes. You don't. Oh, sorry.
Share button at the bottom. Yeah, that's coming.
Okay, should I go from the start or continue?
No. I think where you were. Yeah.
Continue from here.
Yeah.
Okay, I'm sorry.
No problem. I thought you were coming to the slides later, but no problem. Just continue.
Yes, okay. Since 2012, the Land Administration Domain Model constitutes the international standard for 2D and 3D cadastral data modeling. Through the last few years, several approaches have been proposed in order to settle a link between the legal and physical counterparts of 3D cadastral objects, while lately the adoption of crowdsourcing techniques in developing 2D and 3D cadastral surveying procedures has been achieved. The most common practices to record the geometry of 3D cadastral spaces are based on the identification and limitation of 3D cadastral objects on the available base maps, such as architectural floor plans, orthophotos, aerial photos, or cadastral maps. In the absence of accurate base maps, there are several options to proceed with, such as the utilization of specialized geometric tools assisting the localization of property boundaries, or even the utilization of smartphones' GPS sensors, or by using external support GNSS tools and resources. However, the GPS GNSS signal is weak in the interior of buildings, and therefore indoor positioning relies typically on local infrastructure measurements and other types of support. For the last case, it has been proven at earlier stages of this research that an indoor positioning system based on low-cost Bluetooth technology in combination with a 3D cadastral mapping mobile application may constitute a promising solution, enabling the gradual construction of indoor cadastral spaces plan through moving the mobile device toward the physical boundaries of each property and digitize them. This may be the case even for regions that still lack a 3D cadastral and 2D cadastral data registration. However, this approach is still under investigation. BIM is considered as the most comprehensive and intelligent 3D digital approach, able to manage buildings with complex structures and enable communication between stakeholders with different backgrounds. At the same time, many cities with complex buildings, regardless of the progress in establishing good land administration systems, are mapped in 3D utilizing building information models. The exploitation of this rich data source that already exists for a large amount of mainly new constructions may be very beneficial for cadastral purposes for the registration of these new properties, as well as to capture possible future changes of use or ownership, saving valuable time. While BIM may be used to provide the geometry of the physical building spaces for 3D cadastres, the legal space needs to be related with only one space describing the ownership boundary of a single property. Through binding a number of physical spaces or their parts, the legal spaces may be defined. Thus, the utilization of BIM data may be very beneficial for cadastral purposes. The proposed crowdsourced approach tends to provide a modern LADM-based technical solution for the acquisition, registration, and representation of 3D cadastral data. In this particular study, the potential use of existing BIM data as a registration background for the implementation of 3D cadastre is investigated. The proposed crowdsourced approach consists of two complementary parts, the technical aspect and the procedure to be followed. The architecture of the proposed technical framework consists of two connected components, the server side and the client side. The server side refers to the web server and therefore to the database management system where the collected data are stored. The client side refers to the communication between the server and the data capturing tool. For the server side, the database schema according to LADM specifications was generated through Enterprise Architect UML modeling tool. LADM's basic classes are preserved and new classes were generated in order to support the geometry of 3D spatial units. A new class named Land Parcel 3D was generated in order to emphasize the basic spatial unit element, and it's directly linked with LA spatial unit class. Furthermore, a new class named Building Unit 3D is generated in order to function as a receptacle of all potential geometries that can be managed by the database. In order to link LADM with BIM, the Industry Foundation class standard was utilized. Through Ifc Space Entity, the representation of volumetric legal spaces inside the building is enabled. With that in mind, a new class named BIM Building Unit 3D was created, describing the BIM cadastral legal spaces. BIM Building Unit 3D class is directly linked with Building Unit 3D class, preserving the necessary information regarding the definition of the volumetric multi-path geometry of a building unit that describes the property. To support the client side of the proposed technical framework, I developed a prototype for Android mobile devices. The mobile application enables the collection of 3D crowdsourced information by non-professionals, the registration of the cadastral data and their relationships within an LADM-based cadastral geodatabase, the manipulation of BIM Ifc descriptive data, and the visualization of real properties. For the development of the mobile application, a set of software tools was utilized. The interface of the application was appropriately designed in order to lead and simplify the registration procedure. It simulated 3D real world utilizing a digital terrain model offered by ESRI. If BIM data describing user's property unit is available, the user may proceed with the cadastral registration process. The user may navigate throughout the 3D scene and change the viewing mode of BIM through the BIM View tool provided by the mobile application. By selecting the BIM View tool, the user may observe the physical view of the building and then return to the legal view of the building by selecting the closing button of the physical view. Once the user locates the property unit, he can tap on it on screen. The application allows the user to capture photos of the property and attach legal documents proving his rights. Following, the user may enter all the necessary cadastral information, including the information form, which the application will ask the user to complete. Finally, the user can store the collected data in the cadastral database, updating the system with new records in the server of the ArcGIS Online. The proposed framework follows an innovative approach for the compilation of 3D cadastral surveys. At the first phase of the proposed crowdsourced methodology, the declaration of an area under cadastral survey and the collection of the available geospatial information is conducted. The area is divided to sub-regions, and each one of them is assigned to a local team leader who is responsible for citizens' briefing, motivation, training, and technical system preparation. 3D cadastral surveys are performed by the right holders by identifying and selecting their property on the BIM and inserting all the necessary cadastral information. Finally, the examination and assessment of objections and the corrections of data is conducted by professionals, leading to the compilation of a preliminary 3D cadastral database. Now, the proposed application was tested in a multi-story building in Athens, Greece. Before the registration process began, some pre-processing steps had to be implemented. BIM data were translated in IFC format, where the cadastral spaces were preserved through the IFC space entity. In this investigation, we assume that the 2D and 3D legal boundaries of the studied properties were correctly cited. Finally, IFC model was converted into a geodatabase and inserted to the cloud of ArcGIS Online. It is noted that the properties of IFC space feature class was enriched with more attributes representing the cadastral information. In order to proceed with 3D cadastral registration, a team of volunteers consisted of NTUA students were assumed as right holders. Also, a member of our research team with the role of team leader was responsible to inform the volunteers about the objectives of this research project and train them regarding the function of the developed mobile application. Once the volunteers were familiarized with the mobile application, the 3D cadastral registration process was started. For this particular study, the collected data include the selection of the property object and the descriptive information about the building, the property unit, and the right holder. Each one of the volunteers was able to navigate throughout the 3D building scene and view the structural and realistic characteristics of the building by enabling the physical view through selecting the respective BIM tool provided through the mobile application. Once the volunteer identified the desired property unit, he was able to close the physical view and view only the 3D legal objects of the studied property. By tapping on the BIM at the position that he assumed that his property was located, the 3D volume presenting the legal space where the rights are assigned was highlighted. Then the volunteer inserted the required cadastral information utilizing the Add Information tool. Simultaneously, the volunteers were able to attach images and legal documents proving their rights in order to verify their declaration. Once the volunteer collected the required data, they submitted their declarations, which were stored in the cloud of ArcGIS Online, updating the system with new records. The registration procedure was completed successfully. The mobile application was easy to use, while the registration process was fast enough with duration about 7 to 15 minutes. The utilization of an alternative, fast and reliable solution is needed for the effective management of land and multidimensional overlapping property rights. The shift to the use of an innovative data collection method, such as crowdsourcing, and the reuse of powerful representational models, such as BIM, may constitute a potential solution. Thank you for your attention.
Maria, for a very interesting presentation. We have some questions coming in. The first is IFC is not usually used for crowdsourcing, as it is used by experts in the domain. How do you support the use of such files for crowdsourcing purposes?
How do you support? Okay. First, I would like to say that the main objective of our research is to establish a more generic framework adjustable to the available cartographing infrastructure of each country, including even regions that still lack to the registration system. Until now, several different categories of data have been investigated as potential data sources for 3D Cadastre. So our main interest is to categorize these alternatives and each time choose the best one. Now, as BIMs are widely used nowadays, they reuse for 3D crowdsourced cadastral surveys seems to be a very interesting aspect. So in cases where BIM and IFC is available, we choose this data source as the best one, as with BIM and IFC format. The 3D cadastral spaces, as maybe through BIM and IFC format, a better understanding is provided for 3D cadastral spaces, which helps the right holders to identify their property and continue with the procedure, the crowdsourced procedure.
Thank you. That also I'm sorry, I'm some technical issues. I am disconnected from time to time. Sorry for any inconvenience. But the next question is, how are the various IFC quality checked, executed at a client or at a server side, or both? If you just could answer shortly.
Okay, how yes, I don't understand the question. Maybe
how do you check the quality?
The quality of IFC. The quality and the correctness of all of the collected data is a very important factor for the success of the proposed framework. So, in the fifth phase of the proposed methodology, the right holders are asked to submit their information, and this information about the ownership and other rights are stored in the database. And then the evaluation and control of the quality of the data is carried out by a cadastral agency in the 6th phase of our proposed methodology, or by cross-checking the legal documents with the declared crowdsourced data, or through publishing the collected data.
Yes,
Maybe I didn't understand the question very well.
yes. What I think what is meant is always an issue how to make sure that the data has a certain quality, or that you at least can describe its quality. It is good enough for the purpose intended or not. But the whole quality issue is a huge complex.
Yes, you mean if the legal spaces are correctly assigned?
Yes, for example.
Yes. At this point of this research, we assume that the legal spaces are correctly assigned, and what is more what we are most interested in at this point of the research is not how to check the quality of the declared legal spaces, if the legal spaces are correctly positioned, but more the technical background based on which the 3D crowdsourced cadastral surveys may be implemented. This is an important aspect that that needs to be investigated, maybe in the next stage of research.
Yes, thank you. You are right. It's a huge issue, huge complex research area. In fact, next question is: you said BIM data have been converted to IFC format. In which format were your initial or raw data? How was the database enriched with attributes? Did you do it manually?
Yes. Our raw data were architectural floor plans, and based on these floor plans, we generate the BIM model, and then we extracted it from the program. We use Revit software to extract the IFC model. So now then we inserted the IFC model to the environment of ArcGIS Pro, and there we enriched and when we inserted the IFC model into the ArcGIS environment, we generated your database, and then we select the IFC space entity, where we add some extra attributes regarding the cadastral information. Yes, we did it manually at this point.
Okay, thank you. We have 2 questions left. What is an EU desired 3D cadastre?
Europe.
Yes, but there are no.
Yes, it was.
But there are no, as you know, no.
European Union. Yes.
European desire for 3D cadastre on overall level in the EU. But I think most EU countries would like a 3D cadastre. Definitely.
Why?
Yes, probably.
Why?
And the last question, are there any limitations in terms of functions and features contained in the mobile application as compared to a desktop version counterpart? That is a lot of technical questions. So
Yes, of course, the functions of the mobile application are less than a desktop version, but programmatically this may be corrected. Of course, with a mobile application, it's preferable because the user may go through his property, and through the GPS of the mobile device, he may understand where he's located regarding the BIM. And this may be more helpful for identifying and selecting his property.
yes, thank you. At last, we had a clarification on the EU question. I mean, in which terms is a 3D cadastre is characterized as EU desired? Well, as I said, there is no official desire by the European Union to create a formal cadastre as such.
I think that is a general need, because current land administration systems are still based on 2D drawings, and they are not being able to cope with the new complex stratified reality. Also, some incorrect registrations, mistake declarations about the property rights are only some of the consequences that the poor management of the increasing multi-dimensional property rights. So I think it's something that is desired in European Union.
Discussed interesting thought, really. And by that, I will say thank you very much for a very interesting presentation and good answers to the questions. And by this session actually has come to its end. Thank you very much, all of you, for participating in these sessions with good presentations and good questions and good technical backup from Peter and Eftychia. Thank you all. And now there is a break of about 2.5 hours, and then we meet again.
There's actually also a plenary presentation again, and so the local organizers have.
Yes, I know. Yes, well, sorry, Peter, you are right. There's a plenary presentation, but I was in our world here.
Cadastre, yeah, right.
So 2.5 hours.
I will take the long. Everybody can watch the next plenary. Yeah, people in Asia, Australia, have a drink and then go to sleep, rest well, watch the video when you have time. Also have a drink, have a good dinner. And because probably should not have a drink, just have a good lunch and see you later. What I will do is I switch on the network floor. So in a few moments, I click on a button and then we leave the presentation mode. See all I stay there because I really will get a headache if I stay too long watching the screen, and I'm hungry also. See you later, after dinner, after lunch, on the video. Jesper, thanks.
Thank you all. Bye.